Hello and welcome to this video where we'll be covering part one of the total lesson. And in this part one, we're going to be covering function operations, where we'll be combining the functions you see in front of us using our main four operations: adding, subtracting, multiplication, and division. So for starters, we'll be using these three functions in all of our examples during this video. So that's something to write down in your notes first before we try any of these examples. And you'll see in a lot of them, we're going to be checking to see if the operation works backwards and forwards, no matter what order you add or whatever function you have first. So in number one, we are adding function f and function g together. So how I probably would write that is keeping each in parentheses to start. So I would have f, which is 2x squared plus 8, being added to g, which is negative x plus 3. And so you have basically just to combine like terms like you may have seen in any other class. And so we are looking to see if we can combine them together. So we have a 2x squared, and you can also maybe just take away your parentheses, the first one, and then the second one, you just remember you're adding a negative and adding a positive. So we have a minus x and a positive 3. And then we're just kind of putting all our like terms together, that being this 8 and the 3. So combining f and g here would be 2x squared minus x plus 11 would be equal to 1. So it turns out if you add these together in the reverse order, if I take negative x squared plus 3 and add that to our original function, 2x squared plus 8. So if I add these two together in the reverse order, well, because of addition here, you would still get the same answer of 2x squared minus x plus 11. So now if we look at the subtraction, so now we have h minus g. So subtraction in general can be a little trickier because we make sure we're careful with minus signs and negative things in general. So if I am doing h is x squared minus 9, and I'm going to subtract g, which is negative x plus 3, well, we know that that is basically going to be just subtracting each of these second parts, and that's going to cause it to be the opposite sign. So we'd end up with x squared minus 9 plus x minus 3, which would end up equaling x squared minus plus x, and then minus 12. And that would be our answer for number 3. Now, if we think about how this same problem would work backwards, we have to consider for 4 that we're doing negative x plus 3 minus x squared minus 9. So with that, we are basically making this whole second part negative, negative x plus 3 minus x squared plus 9. Well, if we figure out what that ends up equaling to, we end up getting negative x squared minus x plus 12. And if we compare these two answers, we essentially have opposites, where our negatives are positives and vice versa. So right now, so far, we can say that if you are doing function operations, the order does not matter with functions when you're adding them, but it does matter when you are subtracting them. And that should make sense if you are considering how that works with adding and subtracting integers or other numbers. Now let's move to multiplying and dividing, which is a little bit harder, but a lot of the same elements are going to be happening. So for starters, for number 5, we're going to be looking at the forwards and backwards of this same thing. So we have f is 2x squared plus 8, and we have g is negative x plus 3. So now we just got to remember we got to use distributive property, and that means that we need to kind of do 2x squared times both, and then 8 times both in the second parentheses. And so that would end up giving us, we can kind of write out all our parts. It's going to end up being negative 2x cubed plus 6x squared minus 8x plus 24. And right there, we don't have any common terms, so it turns out it works out nicely that we will be able to kind of multiply this all out. So if I was going to reverse that process and do the exact opposite order, well, I would be kind of doing the same exact thing. Well, I have negative x times both of them and negative x times 2x squared. And then I have 3 times 2x squared and 3 times 8. Well, that, if I kind of follow those arrows, I get the same order here, because I basically would have the negative 2x cubed, and then I would have the negative 8x, the 6x squared, and the 24 again. So we can say that number 6, it would be the same answer as well. That proves that we have multiplication works the same way backwards and forwards, just like we did with addition. Now we can do our last operation, which is division. So for f, we know that for number 7 here is going to be 2x squared plus 8. And that is being divided by g, which is negative x plus 3. So at first glance, there's nothing we can do to divide those, and we're not going to worry about polynomial division right now. But essentially, we're just kind of worried about setting it up correctly. And we could try to factor the top and bottom to see if that would work out. The top one would factor to 2 times x squared plus 8. And the bottom would just be negative 1 times x minus 3. So that obviously didn't get us very far. And that's as far as you could take that problem. In number 8, if we flipped our fraction basically upside down, we would have g, negative x plus 3, and we would be dividing it by f, which is 2x squared plus 8. Obviously, that is different. Those are not equal to each other. And we can assume that, well, division is not the same backwards and forwards. So lastly, like with other kinds of function operations, you might also need to evaluate the answer at a certain x value. So for instance, in number 9, we're doing f plus g and then of 2. So 2 is basically, we're figuring out what is going to happen if x is 2, and we put it into the result of f plus g. So if you recall, this 2x squared minus x plus 11 number is what we got from f plus g. And so I'm really just going to put in 2 times 2 squared. And I'm going minus 2 and then plus 11. And I always like to put the numbers I'm inputting in parentheses, so I know that was something I added and not something that was in the expression or function originally. So I would just need to then take 2 times 4 minus 2 plus 11 and put that in a calculator or solve it using mental math. In this case, it would be 8 minus 2 is 6. 6 plus 11 equals 17. And so we'll do the h minus g next. So h minus g was number 3. So number 3 was x squared plus x minus 12. So I'm going to copy that down here. So h minus g was x squared plus x minus 12. And I'm going to put a 4 into x. And I'm just going to evaluate that answer. So I have 16x squared plus 4 is 12. Or is 20, I mean. 20 minus 12 would be equal to 8. We're just going to skip 11 for now, since that's basically the same as number 9. So f over g was 2x squared plus 8 divided by negative x plus 3 as a fraction. And we're going to see when x equals 0 what we have. That would mean we would have 2 times 0 squared plus 8 over negative 0 plus 3. Well, those 0 terms will just cancel out, and then we end up with just 8 divided by 3. And that covers all 4 operations when we are combining functions using all 4 of them. And that concludes part 1 of this lesson.